Alright, so let's take a look at these problems. We're looking at skill packet 5, exponential and logarithmic equations, and in 5F we're solving logarithmic equations. You definitely have to know the properties of logarithms, those formulas that are in your skill packet here. You need to know these equations. And so when we look at this, however, we don't have this is not log times, so we don't have a distributive property. We can't say this is log base 3 of 5 times x. And on the right hand side, that's not a logarithm, so I can't use my one-to-one functions and say that x plus 5 is equal to 2. That's incorrect. So about the only thing that I can do is recognize that this equation is in logarithmic form, and I know by the definition of a logarithm that I can change this equation to an exponential form, one that I'm more familiar with in solving equations. So I've got this base of 3. A logarithm equals an exponent, so it's 3 squared is equal to x plus 5. So 3 squared is 9. If we subtract 5, 4 plus 5 is 9. Now, plug in 4 and you're taking the log of a positive value, so it's not extraneous, so we're good here on number 5. On number 6, it's on the left hand side, I have the same base and I have a sum of logs by the product rule. I can write that as a single logarithm. I can write this of log base 6 of x times this binomial x minus 5. But now on the right hand side, I have 1. Now here it's pretty easy to rewrite this as log base 6 of 6 without much thought. Sometimes before, with a base of 3 and this number 2, I really can't come up with integer values that I can think of to quickly rewrite this to. Well, yeah, I guess I can. Log base 3 of 9, because 3 squared is 9, and then x plus 5 is equal to 9. I could have done it that way, but many times it's easier to just go from log form to exponential form, including here in problem 6. But like I say, I'm so used to seeing log base 6 of 6 as being 1, I know this x times x minus 5 is going to equal 6, even when I convert it to an exponential form here. So you can see that if this is my log form, that written as an exponential equation, the base is 6, a logarithm equals the exponent, and we've got x times x minus 5. So this is a quadratic equation. Let's write it in standard form, try to see if we can factor it, and if we can't factor it, we'll have to complete the square or use the quadratic formula to solve it. So we've got 6 is equal to x squared minus 5x. We need it in standard form, so we need it set equal to 0. So I need to move the term to the other side so it changes sign. And this time I believe I can factor this. We've had previous problems where we had to use the quadratic formula. X minus 6 times x plus 1. The negative 6 times the positive 1 gets me negative 6, but yet when I add these together I get the negative 5. So I get a possible solution here of 6 and a possible solution here of negative 1. Well, I'm going to have to throw out that negative 1. I can't take the log of negative 1. So that's extraneous. Now 6 minus 5 is positive, so hey, this is okay. Alright, so well, I'll stop there and do the next pair in another video, so I hope that helps.